Our story begins in a quiet corner of the Milky Way Galaxy. The Milky Way is a vast spiral of stars, gas, and dust. If you could see it from afar, it would look like a giant shimmering pinwheel. Our solar system, a humble collection of planets orbiting a single star, resides within one of the Milky Way's spiral arms. Imagine yourself shrinking down, smaller and smaller, until our sun is the size of a grapefruit. Even at this scale, the nearest star would be thousands of miles away. The vast distances between stars are difficult to comprehend. Our galaxy alone contains hundreds of billions of stars, each potentially hosting its own planetary systems. Amidst this cosmic expanse, our solar system represents a tiny island of activity. It's a place where planets dance around a star, sculpted by gravity and time. Their story is one of cosmic drama, a tale of birth, evolution, and constant change. It's a story that begins, as with many things in the universe, with a cloud of dust and gas. Imagine a vast dark cloud, a nebula, adrift in the emptiness of space. This nebula is not empty, it's filled with tiny particles of dust and gas, the remnants of long-dead stars. These particles drift and collide, their movements seemingly random. But something is happening within this chaotic cloud. Gravity, the invisible force that attracts all matter, begins to exert its influence. Slowly at first, almost imperceptibly, the particles in the nebula are drawn towards each other. As more and more particles clump together, the gravitational pull intensifies. The cloud begins to collapse in on itself like a deflating balloon. As it collapses, it spins faster and faster, a cosmic dance dictated by the laws of physics. This swirling cloud, a maelstrom of dust and gas, is the birthplace of our solar system. At the heart of the collapsing nebula, something incredible is happening. The immense pressure and heat generated by the gravitational collapse are so intense that they ignite a nuclear furnace. Hydrogen atoms, the simplest and most abundant element in the universe, are forced together, fusing to create helium and releasing an incredible amount of energy. This is nuclear fusion, the engine that powers the stars. And with its ignition, our sun is born. The sun, a giant ball of hot, glowing plasma, becomes the gravitational anchor of our solar system. Its immense gravity holds the planets in their orbits. Its light and heat provide the energy that makes life on Earth possible. While the sun blazes at the center, the remaining dust and gas in the nebula continue to swirl around it, forming a flattened disk called an accretion disk. Think of it like a giant cosmic pizza dough being spun by a chef. Within this disk, the process of planet formation begins. Dust particles, drawn together by electrostatic forces, begin to stick to each other. It's a bit like rolling a snowball. As the snowball rolls, it picks up more snow, growing larger and larger. In the accretion disk, these growing clumps of dust and ice are called planetesimals. Over millions of years, these planetesimals collide and coalesce, gradually growing larger and larger. Some of them become massive enough to exert their own gravitational pull, attracting even more material and growing into protoplanets. As the planets formed, they interacted with each other through their own gravitational pull. This gravitational dance shaped their orbits and ultimately determined their fates. Jupiter, the largest planet in our solar system, played a particularly important role. Jupiter's immense gravity acted like a cosmic shepherd, herding smaller objects in the early solar system. It prevented a planet from forming in the region between Mars and Jupiter, leaving behind a collection of rocky debris, the asteroid belt. This belt, a graveyard of failed planets, serves as a reminder of the chaotic early days of our solar system. Section 6. Mysteries in the deep freeze, the Oort cloud, and beyond. Far beyond the orbit of Neptune, the outermost planet, lies a region of icy bodies known as the Kuiper Belt. This region, a vast and mysterious realm, is home to dwarf planets like Pluto and countless icy objects. But the Kuiper Belt is just the tip of the iceberg. Even further out, stretching halfway to the nearest stars, lies the Oort cloud. This vast, spherical shell of icy bodies is thought to be the source of long-period comets, those icy wanderers that grace our skies every few centuries. The Oort cloud is a relic of the early solar system, a repository of icy planetesimals that were flung outwards by the gravitational influence of the giant planets. Section 7. Building blocks of life, comets and the ingredients for life. Comets, those icy messengers from the outer solar system, may hold clues to the origins of life itself. These cosmic snowballs are composed of ice, dust, and organic molecules. When a comet approaches the sun, the heat vaporizes the ice, creating a glowing tail that can stretch for millions of kilometers. Scientists believe that comets may have played a crucial role in delivering water and organic molecules to the early Earth. These ingredients, essential for life as we know it, may have been brought to our planet by a barrage of cometary impacts billions of years ago. Section 8. A continuing story, the ever-evolving solar system. The story of our solar system is not over. It's a story that continues to unfold today, a tale of constant change and evolution. The planets continue to orbit the sun, their paths shaped by gravity and time. Asteroids and comets still hurtle through space, occasionally colliding with planets and moons, leaving their mark on the solar system. Even the sun is changing. It's slowly brightening, its energy output gradually increasing over time. This will have profound consequences for life on Earth, eventually making our planet uninhabitable. Section 9. A universe of wonder, reflections on our cosmic origins. The story of our solar system is a reminder of the vastness and wonder of the universe. It's a story that began billions of years ago with a cloud of dust and gas collapsing under its own gravity. From these humble beginnings emerged a star, planets, and ultimately life itself. As we gaze up at the night sky, we are reminded that we are part of something much larger than ourselves. We are children of the cosmos, born from the same stardust that makes up everything we see. And as we continue to explore the universe, we unlock more secrets about our cosmic origins and our place in the grand tapestry of existence.